Welcome. Let's solve this question on linear programming. A farmer has 60 acres of land on which he plans to plant maize or beans. Each acre of maize requires 1 man and each acre of beans requires 3 men. The farmer intends to use a minimum of 60 men available and he must plant at least 15 acres of maize. The profit on maize is 1,000 shillings per acre and on beans is 2,000 per acre. If he plants acres of maize and Y acres of beans, part A of the question, write down 3 inequalities in X and Y to describe this information. Then B, represent these inequalities graphically. And then part C of the question, use your graph to determine the number of acres for each crop which will give maximum profit and hence find the maximum profit. So let's go to the first part of the question where you're supposed to write down 3 inequalities in X and Y to describe this information. The farmer has 60 acres of land on which he has to plant maize or beans, and each acre of maize requires 1 man and each acre of beans requires 3 men. So let's go to the last statement where we're given that we let the acres of maize to be represented by X and the acres of beans to be represented by Y. So since he has 60 acres from the first statements and the acres for maize are X, acres for beans are Y, we therefore can write the first inequality from that statement that if we take the acres of maize plus the acres for beans, that should give us 60. So he has 60 acres of land. So that means X plus Y should be either less than or equal to 60. It can't be greater than that since he has only 60 acres of land. So it is either when you take the sum, acres for maize and plus acres for beans, it should be less than or equal to 60. That is the first inequality. Now the second inequality, we'll get it from this one. So the farmer, each acre of maize, this one requires, for maize requires 1 man, and then for beans require 3 men. And then the farmer intends to use a minimum of 60 men. So from this statement, we will be able to form another inequality. So 1 acre of maize requires, or each acre of maize requires 1 man. Each acre of beans requires 3 men. So in total, the acres for maize will require how many men? If 1 acre of maize requires 1 man and you have X acres, what about X acres? We require X times 1, which will be X. So for maize, it requires X men. If 1 acre requires 1 man, what about X acres? That is X times 1, which is X. Then we add, we are getting the sum because there are 60 men available for both maize and beans. So for beans, each acre requires 3 men. What about Y acres? To be 3 times Y men. So that will be 3Y. So this is the sum that is required for both acres of X acres of maize and Y acres of beans. And since he has 60 men available to do this job, so we can say that X plus 3Y, which represents the total number of men required for both acres of maize and beans, should therefore be, what do we mean by a minimum? A minimum of 60 men. Minimum of 60 men means they should either be greater than or equal to 60. It cannot be more than that. Or in other words, you can say at least 60 men. He intends to use a minimum of 60 men or at least 60 men. It means the same. So it should be greater than or equal to 60. So the minimum being 60. It can be either greater than 60. So that is the second inequality. And the other statement here, and he must plant at least 15 acres of maize. The acres of maize are represented by X. So acres of maize should be at least 15. At least 15 means the acres of maize, which is represented by X, should be greater than, at least mean greater than or equal to 15. So that is the third inequality. So we have written the 3 inequalities that you are supposed to write. From the other statement, the profit on maize is 1,000. That one will not have any inequality. We are going to get the objective function from that statement. Now, the other inequalities that we can add, since we are talking about the acres of maize and beans, they should be non-negatives, and we can add these, that the acres of maize should be greater than or equal to 0, and the acres of beans should be greater than or equal to 0. So they should be non-negatives. So once we've done that, we can go to graphing. So part B, represent these inequalities graphically. So let's go to the first inequality, x plus y. So the first one is x plus y is less than or equal to 60. So the line that you're going to draw there is x plus y is equal to 60. We are going to draw that line. We require at least 2 points to draw that line. So let us have the 2 points. So you can use when x is 0, you substitute in that equation, y will be 60. And then when y is 0, x will be 60. So that is the line that you're going to draw. Then for the second one, x plus 3y. So x plus 3y you're going to draw the line you're going to draw there is equals to 60. Is equals to 60. So again, we should have at least 2 points to do that. So again, when x is 0, y will be 20. Then when y is 0, x will be 60. So that one is okay. And then we have the other one, x is greater than or equal to 15. So the line that you're going to draw there is x is equals to 15. And that line will be continuous. So the first line here, this line will be continuous. Remember, this is less than or equal to. So this will be a continuous line. And then also this one, the second one, is greater than or equal to. This one will also be continuous line. And then this one is greater than or equal to again. So this one will also be a continuous line, not broken. And those are the lines that we need to plot. Let's go to the graph and plot them, that we draw the inequalities. We start with the first one. The first one is x plus y, that was less than or equal to 60. So the line there is x plus y is equals to 60. So we plot 0, 60. I've used the scale 1 centimeter to represent 5 units. So for the y-axis, we have acres of maize. For the x-axis, we have acres of beans. So the first point is 0, 60. 0, 60 should be here. 0, 60 should be there. Then we have a 60, 0. 60, 0. That line should be continuous. So that is the line. Draw the line properly. That is the line. X plus y is equals to 60. Now we need to determine the side that you're going to shade. And this is how we do it. So x plus y is less than or equal to 60. That is the equation of the inequality representing that line. So we choose a point on either side, either this side or this side. So I'll choose the point on this side. Let's say 0, 0. And then I substitute 0 in x and 0 in y. So on the left hand side, x plus y, that will be 0 plus 0. It will be 0. 0 is less than or equal to 60. So does it satisfy the side where I have picked that point? Is it satisfying? 0 is indeed less than 60. So that side satisfies the inequality. So automatically the unwanted side will be the opposite side. We can't have two sides satisfying the inequality. So automatically any point that you pick on the side that I'm shading will not satisfy the inequality. So that point I've picked has satisfied the inequality. So that is the required region. So you shade that side like that. We draw the other line, which is the second, x plus 3y is equal to 60. So 0, 20 is the point. 0, 20 is here. And 60, 0 and 60, 0, the same point here. Let me draw. The line should also be continuous. So that is the line. So that is the line. So x plus 3y is equals to 60. So again, I want to know the side I'm going to shade. So this one was greater than or equal to 60. So I'll pick a point on this side. You can pick either. So 0, 0 again. So when I pick 0, 0, I substitute x with 0 and y with 0. I'll get x plus y will be 0 is greater than or equal to 60. So is that okay? 0 is not greater than 60. So meaning this is the unwanted side. Remember, in inequalities, we always shade the unwanted sides. So since this side where I have picked my point 0, 0 and substituting it, it has not satisfied that inequality. 0 is not greater than 60. So I shade that because that is the unwanted side. So like that. The other point, the other line is x is equals to 15. X is equals to 15 is this vertical line passing through 15. So that line, and that line is also continuous. So this is x is equals to 15. Now the inequality is that x should be greater than is the right hand of that line. That is the one that is required, the right hand side of that line. The left hand side of that line is less than 15. So it is the unwanted side. The side that is greater than the inequality, remember, is x is greater than or equal to 15. The required side is the right hand side. So we shade the left hand side of that line. That is what you're supposed to shade. That is the unwanted side, like that. So now you can see we are remaining with this region here. This is the required region, and this region is also referred to as the feasible region or the required region. And any point that we pick in this region will satisfy 3 inequalities represented by these 3 lines. Let's go to the other question. Let's go to the other question now. So the other question is use your graph. See that? Use your graph. Yeah. Use your graph to determine the number of acres for each crop which will give maximum profit. So that is the question. So you are required to maximize. Now, when you remember in the question we had been given, we need to get the objective function. And from the statement, we had something that we are going to use to get the objective function from the statement. So from this statement, you can see there is a statement there. The profit on maize is 1,000 per hectare and beans is 2,000 per hectare. So that is what you're going to use to get the maximum profit. So 1,000 per hectare of that is for maize, 1,000 per hectare. So remember per acre, I'm sorry. So in order to work out that question, we will get the objective function. That is what I want to note here. The objective function. This is what we use to optimize to get the minimum or maximum. Right? So remember we have x acres of maize and the profit per acre of maize is 1,000. So that will be 1,000 x or x acres of maize. Then profit for the beans, the acres of beans, we have 2,000. So 2,000 and the acres of beans are y. So profit on all the acres, y acres will be 2,000 y, like that, is equals to the profit. This is what is going to give us the cost or the profit. So this is the objective function. This is what you're going to use in order to find the maximum profit. Now I want us to use a different method to find the maximum profit, and that is the inspection method. Now in this method, you always test at least 3 points, and you test the corner points, of the feasible region, So look at the graph here. You have the graph is here. So look at the corner points. So we have these. So we're going to take this here, which is a 60, 0. We test that. So we shall test 60, 0. Then we can test another one here. This is a 15, 15, did 15, this one, 15, 15. And we can also test 15, 45, 15, 45. So those are the corner points, 15, 45, that. So let us test them using the objective function. We test them using the objective function right away. So the first one, we have 1,000, x is 60 plus 2,000, x is 0. So we get the solution for that. Then the second point is 15, 15. So we take 1,000, x is 15 plus 2,000, x is 15. We get the solution for that. And the third one is 1545. So 1,000, 15 for x, and then 2,000. This is 45. So let us get the solutions for these. So the first one we have 60,000 plus that, this will be 60,000 flat. Then the second one will be, this is a 15,000 plus this will be plus 30,000. This will be 45,000. Then the last one will be 15,000 plus this is a 2,000 multiplied by 45. This will give 105,000. So now, because you're finding the maximum profit, the number of acres of maize and beans that will give maximum profit, we check the one that is giving us the maximum, the highest profit. This is 105,000. So the acres that will give a maximum profit are 15 acres of maize. So 15 acres of maize and 45 acres of beans. So that is how you're supposed to solve that question. Thank you.